If we begin with the code, we found how we should deal with independent variable. Suppose we have x3. If we want to draw a minus x3 plus 1. How would you go? At first, we go through time shifting. It's plus 1, which means we should move to left, exactly. Minus 3, minus 1. Amplitude is not changing. I'm looking for in minus 2t plus. I made ht plus 1. After that, I should.
But this one shouldn't be in this one.
After that, we should make x 2t plus 1. How do you do that? Exactly. We divide this scale by this coefficient, 2, which is minus 3 over 2, minus 1. The amplitude again not changing. After that, we want x minus 2t plus 1.
Divide by shift it to the positive axis.
Yeah, we need to do time reversal. It should flip or mirror this regarding to vertical axis. It should be like 1 over 2 equals me. Yeah, after we do time shifting, after that scaling, after that time reversal. That's the process. You can do that. You mentioned, okay, I can give a factor like this. You go through minus 2 at the end of 2 shifting. You can, but that's the you don't need to go. That's the you can do that. Wrong, but for me it is easy. If for you that's easy, you do that. It doesn't matter. We went through time shifting. We talked about what is the even and odd mode of signal. If we have a signal, we can make it even mode with this equation, and it's odd mode with this equation. And we talked about periodic signal. And we went through until, and here we talked about the sampling property of impulse unit, which was if you multiply impulse unit by any function or any waveform, you will only have the waveform exactly at the point of impulse. If I have one impulse at equal 1, what is the expression? If you want to write the expression for the waveform,
That's minus.
that's delta t minus 1. If you have sine of what is the result? Which means we are multiplying the time by delta. It's 0 in all time except t equal to 1. And we only have value at t equal to 1. How much is the value? I need just replace t by 1. Sign of pi over 2. 1, which is delta t minus. If we had sign of pt, how much is sign of p?
Yeah.
0. This was 0 on that day. We are focusing only on single input, single output, continuous time system, which we will see the discrete time when we are talking about A to B. But before that, we just deal with continuous time system. So the connection we can connect systems. Three, we can connect them parallel. Combination of that and this is the feedback form, which is one of the most important. We will talk about it at the end more. Let's give you some properties of the system. A system is memoryless if its output at any time depends only on the input at the same time. Which means if I'm looking for y at time of 10 seconds, it should only depend on x of 10. Here I can have a function of t. For example, if I have sine of 2t minus 1, here time would be 19. Yeah. If I put 10 equal to 10, t equal to 10. But it doesn't matter. The only important is x should be at the 10. Let's see this example. Here, if I'm looking for y of 5 seconds, if I put t 5, x would be x dot 5. They are exactly at the same time, which is this memory. How about this one? Derivation of HT. Is it memory? Why?
Because it's changing with time, it's not.
Changing with time. What does it mean? This one is changing with time.
Depends on the past inputs.
How come? It depends another time. But how come? What is the definition of derivation?
So previous time minus.
Yeah, that's derivation of that's definition of derivation. Which means here we depend on a time a bit after t. So for derivation I need 2 different times. So it is how about this one? Obviously we are depending from t minus infinity to exactly to current time. So it's obviously with how about this one? Here I have xt only here. These are just coefficients. Okay? They are not inputs. Our input, I have one xt input, one xt delta. These parameters are coefficients. They are not input. So integrity at any point depends on only xt at that point. So that's memories. How about this one? It depends one entity here, another, which means if I want x1, it depends to x0. So y1 depends to x0, which means another time. So that's means. Well, these are the discrete time, but just let's I'm looking for yn. The difference between t and any discrete, it only can be integer value. It's dependent to the x. y1 depends to x2. So that's with memory. How about here? Y depends to this one or this one. They are not even same time. So that's with memory. Is it clear? I think.
If it is within the same time and previous, it has memory, right?
Is
If it depends on the same time and previous time, then it has memory. Otherwise, it is.
so it is based to future. Here, y1 depends on x2. Yeah. See, that's with memory. Yeah, that is not causal system. We cannot make it. Yeah. It's predicting the future, but still with memory. Causality means a system that we can make it. Its output shouldn't depend on the input on future time. Yeah. Exactly at the time or past time. We call it causal system, which we can make a causal system. Yeah. Every memory-based system is causal up here. It depends on the current time. But every causal system is memory-based. So it can depend on the past. The system we can make it, we can generate them, they should be, but they are not able to predict the future. Is this a system causal or not?
First,
Why not?
minus eight.
So how come?
Depends on the past value.
If it depends on past value, it should be causal.
Yeah. Because if t is negative one,
Exactly.
it will be one.
y1 depends to y minus 1 depends to x1. This time is future for this time. How about this time? xt minus over. It only depends on the past time. How about this time? Obviously,
Infinity.
but y1 depends to all x. This one exactly depends on the x, so it's causal. This one x here, another x here. Again, causal. This one.
And one x is two.
Yeah, again, one depends on x3. How about this one?
Same figure, and then 0 minus 1.
Exactly. X minus 1 depends on x1. If it goes plus,
close, okay.
It was cotton or not?
Yes, present.
So,
Where if it is positive here?
yeah, it minus n was positive n. Which is in the top side we had xn, not x minus n.
Should be closing.
It should be cotton. X minus 2 depends on how about this one.
It will be negative one.
Which one is future? This one. Yes. So again, it wouldn't be cotton. Time variant, the system we call it timing variant when its characteristics don't change with time. What does it mean if you apply input today, you see the output, if you go and come back tomorrow again apply the input, you should see the same output, nothing should change. If the output for x is exactly, if I change t to tomorrow, t minus 2, I will have this. If I come tomorrow and apply the same input, I should see the result. These two should be equal. That means once you apply XCT, you see negativity, you just time shift the negativity. Another time you just time shift XCT and see negativity, they should be same. There are some rule of thumb. If variable t appears outside the argument of x, like what? Can you give one example here, like this? Like this, yeah, like this. If variable t is outside the argument of XC, it's usually time value, time value. If we have time shift, it's okay, still your timing variant. If we have scaling or reversal and reversal, it can affect time variant. Let's see some example. This one, we have time reversal. Okay. Probably it should be time variant, but let's check. If I apply XT, this is aggregate, I need to change all t to t minus t0. So this would be the result. Another time, I apply x1t, which is xt minus t0. Here, if I put x1t as the x as x1t, I will have this one. If I change t to t minus t0, this would be the result. Are they same? No. Here we have it. So since we had one time delta here, we could get this time value. How about this one? Before seeing the answer, just based on those rule of thumb, can you say it
Time
by
there's no reversible T outside there.
there's no T outside? Are you sure? I can't see obviously there is a T outside. It doesn't matter T at the coefficient or at the condition. I have T here. That's outside. Okay, let's see. If I change all T to T minus T0, would be I will apply x1t instead of xt and after that I will change T to T1. You see, there is a difference. This condition depends on Dt, it would be time varying. Stability, which is one of the most important parts for us in designing the system. If I have a limited output or if I have a limited input, our output should be limited. Do you remember this one? That was output. This is the one example of unstable system. You have a small, for example, you have a small entity like one constant, and your identity will be something like that. So for a small input, your output is growing with time. We call it as a unstable system. If we have and limited input, our output should be also limited. Okay. Is this one stable or not? This system is entity limited value. Its maximum is A, so its square maximum would be less than A2. So infinity would be smaller than the value, so that stable. Another one of the most important properties is linearity or nonlinearity. We talked about this in circuit. Do you remember if I had a circuit here, I had R and dependent sources. I could separate independent sources as the input. And I could say, okay, every voltage or current you have here, if this is VS, IS, every current or voltage would be alpha VS plus beta. Yes. Which means if you multiply IS by 2, here we could easily multiply this by 2. If we multiply both independent sources by 2, we know output would be multiplied by 2. I asked the same question in the exam. Anyone could help me? Yeah, you're wrong.
Yes, it will be double, right?
Yeah, it will be double. Why? Because the system is linear. What does linearity mean? Linearity means if our system has these two conditions, homogeneity and additivity. Homogeneity means scaling. If you multiply input by a coefficient, the output should be multiplied by same coefficient. If you add two inputs, the output should be summation of the output. For example, if I have a system is output to the X1T, X1T. If I change input to X2T, it would be X2T. If I apply both together, the output should be summation of both. Yeah. What is we call this in circuit? I have a circuit, I applied once one input, another time, another input. Exactly. That's superposition. At the end, I can say the answer is summation of our outputs. So let's see how we check the linearity. Is this one linear or no?
Because there is a sign.
In general, the linearity is something like that. A negative should be ft. It should be a coefficient by x. Yeah. If you apply any function on x, that which means you are changing its domain. If you add something here, a negative xt plus 2. Is it linear or no?
Does it tell us to look for the original? Me.
I'm asking you. You're asking me again.
The question is linear.
Is it linear or not?
Linear.
Linear.
Not
Why?
because if we multiply
By 2, the output would have
yeah, would it be the same?
exactly. Yeah, that is true. It's not linear. It's when you, if you, as your friend mentioned, if you multiply x by 2, is it equal to 2 again? No. Not linear. Yeah. It should provide 0 input should provide 0 output. If you set x is 0, you will have negative. How about this one? How we check linearity? If I apply its quantity, its quantity would be the 1 over dt. If I apply x2, x2 would be, I only change x to x. Now, if I apply x3, which is alpha here, which is alpha x1 plus beta x3. In this case, if I check it should be alpha x1 plus beta x2. Okay, here I change. Here I change x30 to x3. Here I apply x3, so it's x3 over g. It should be alpha x plus beta x2. It's I here. Alpha is constant, I can take it out. Alpha x1 t over pt plus beta. What if it y1? So what if this one? Right. So x3 alpha gradient plus beta gradient, which is same as this one. So this is linear. How about integral? It should be linear. If we write the exact procedure, we will find that linear. How about this one? Is it linear or non-linear?
Okay.
Right? Let's check. You are setting baseline, you count of the root, but if you want to check, x1 is t, x1 would be x1 squared. Right, apply x2, x2 would be x2 squared. If I apply x3t, x3 should be alpha. negative alpha beta. So negative would be if I stop this x with x3. Which is alpha x3. Is it correct? Is it alpha square x1 x2 square x2? What is it? It is x2. Yeah. We expected this value, but this is extra, which means yeah, this system is non-linear. You clear how to you have it, so it should be this way. What is invertibility? Invertibility, if I apply for any input, we should only have one out. And vice versa. Here, if I apply xz, if it comes at -1, the negative would be if I apply xz equal to 1, the negative would be 1. If I apply xz -1, the negative would be again 1. So if you want to find xz from a negative, you know which one you should choose. You saw a negative 1, you cannot find x. Okay. Which is that invertible. Okay. Invertible means for any input you should have only one output and vice versa. So this was the properties of the system. After this, we are dealing with LTI system, which is linear time invariant. Why they are important? Because we can use convolution in LTI system. What is convolution? Convolution is saying if you have the impulse response of the system, you can find its response to any input. Okay. The only thing is you should find the impulse response. Why we are interesting in LTI system, as I mentioned, it's easy to analyze them because if you have the impulse response, which means you know the system behavior, you can find its response to any arbitrary input only by convolution, and you will find that if we go to Laplace and Fourier transform, you can see that it's easier to find the response with only Fourier and Laplace transformation. Okay, let's go to, we are focusing only on single input and single output. Okay. If we have any input signal we can write them with impulse signal with delta. How? You remember if I had x t, if I multiply it by delta t, which means I could get a sample from x t at time 0. It was x0 delta t. If I multiply that by delta t minus 1, which I have x1 delta t minus 1. If I start to multiply it by different delta, which have a time shift, and I sum or add them together, I will construct xct again. The construction of xct with this summation. This is definition of delta t. I have a delta t. I just shift it and multiply it by xct. If you delta, I shift it and multiply it by xct. So I add all together. So if we find it lean when delta is becoming smaller, which is approaching to 0, I can change the summation to integral. So for any signal you have, you can express it with the integral. It's integral of impulse. Here you can see xt for x1, suppose we want x1 minus infinity to infinity x tau delta 1 minus beta. Where this is defined, this delta is defined only
That one.
at 1, which is x1. That's a constant. I can take it out, and we only have delta 1 minus tau beta. How much is this integral? Integral of delta
Summation.
integral of delta
One.
1. Integral of delta is only. So this is x1. For all other x's, x2, x3, that's the same. So we can express any signal with integral of impulse signal. So if I have h tau t, which is impulse response of the system, what does it mean? I have system, I apply delta t as the input, and I saw identity, I write it as the h tau t. So if for any arbitrary input, I can write this expression, which I can define any x with the integral of delta, and that is since system is linear. If system is linear, I can change delta t to this response. You know how it happens? Let me write it. I applied equity ability for any input Suppose x is delta X. If x is delta, the output would be again h tau t delta tau. Yeah. This one is independent of tau. I can easily take it out, and the integral of delta would be 1. Yeah. For any input, since I can move easily HT and XT, I can easily swap them because that's a linear system. Those things, it is linear. I could easily write any response with this expression. If the system is time invariant, which means I can write h tau t equal to t minus tau. This is time shifting. If the system is time invariant, we can easily do time shifting. So at the end, we will have the important thing you should memorize this one. We call it as a conclusion. So we had two conditions here. First one, system linear. Second one, time invariant. If the system is linear and time invariant, we are allowed to use the expression, which is we call it convolution for time LTI system. I can write it in another way. I can write x t minus tau h tau theta. Yeah. They are it doesn't. Okay, let's see how we do convolution integral. Here it means, but what is the edge? Here, what is the edge?
That's the spot.
Impulsive one. Which means if you have impulsive one, it doesn't matter what is the edge. You can find a edge for any. It would be convolution of XTP impulsive one. Okay, let's see how we do convolution. Suppose we have for XTP e to power of minus 80 ut and HT is a ut. What should I do? At first, I should find x tau. I just change the t to tau. I change independent variable from t to tau. So this is x tau. X tau is e to power of minus a tau u. And here again, I change variable to h tau. H. I'm looking for ht minus tau. And then I make h tau. After that, I should, if I have h tau, how I should make ht minus tau?
It is time invariant.
No, it's time invariant, but you have a function ht thing we found. You want ht minus tau. The independent variable is tau, not t. Suppose you want h1 minus tau. What should you do?
We have two steps actually.
Yes,
First, we have to
first. So that's not first.
multiply by minus.
Multiply, I can see multiply. That's time shifting.
Yeah.
At first we should do time shifting to right or left by right. To left, that's +1. For -3, that's right, that's plus, so I go to left. So if I have H down like this, okay, I will write it here. H tau +1 is like, yeah, I move 1 unit to left. Now I need to change tau to minus tau. H minus tau. Okay. Now we should tau 1 by t. I'm looking for H minus tau plus t or H t minus tau. I'm looking for that. But t is changing. Yeah, okay. I can consider t now for suppose t is smaller than 0. Is a negative value. So I have h tau. How is h tau plus ht? Since t is negative value. It goes to right or left?
Right.
It goes to right. Since t is negative value, it would be something like that. Yeah. T is negative value. Now I change tau to minus tau. I change t to minus. Sorry, I change tau to minus tau. So, which means I should do time reversal. It would be something like this. And minus t would be, but since t is negative. So, which means now we are in this situation. T is negative, and this is x. So if we multiply them together, what will happen? 0. Here for tau smaller than 0, x tau is 0. 0 multiplied by ht minus tau is 0. For tau bigger than 0, h is 0. So the answer would be 0. If t is positive, which means I'm doing time shift and I'm bringing this waveform to the right. And now t positive. What is happening here? Here. They are covered together only in the they have one small overlap. Depends on the so if I write the expression of x tau is what is the expression of x tau here? exponential in power of minus alpha. Here, what is the expression of ht minus tau here?
It's one.
1. It's a constant value. So multiply by 1. So what should be the integral start and end point?
From 0 to t.
Yeah, exactly. From 0 to t. So easily we can like 0 to t. This is x tau, h tau. Maybe 30. This would be. I can move t until to infinity. If we don't have more than two different regions. Is it clear?
Yes.
It is so simple for you. It's in your getting book.
Understand.
You are just I thought you are saying, oh, that's so simple. Why you are explaining this one? Yeah. If it's really basic for you, just let me, I can go back. If you think it's okay, we can continue. Okay, another example, we have ht like this and ht. Anyone can explain which one is better for you, for us to consider to keep one of x or h constant and treat another one. Which one is easier for you to treat?
X.
X. Here we have h. Can you solve it by yourself? Just treating by x. And your answer should be the same with this one. Here, because it doesn't matter. I mentioned here we are. If we solve this one, we treating x. You do this one. You just treat h. Okay. Finish by. And that's conclusion. It's not easy to say on the air. It's much easier to treat x. Like that. What you are supposed to make, you just have h tau, you should make x t minus tau. At first you do that, treat t from minus infinity to infinity. X you just need to change the part. Yeah. That's it. beyond PT. After that, you should find a T minus tau. If you take tau, your independent variable is tau, not in that limit. The T minus tau. At first, you should shift it regarding to T, and after that, time delta,
It will be the same as XT.
it will be the same as,
XT.
yeah, but starting at end point of this shape would change. Here it's 0 and capital T. If you do that, the starting point gonna go to
It will be
T
negative
minus
T
capital
zero.
T. No, you are moving that. That's HT. This is HT. Okay. Yeah. H. At first, I need to do HT plus.
Yes. It will go left.
Left or right, I don't know. I just know here would be T plus T minus T. Here would be minus. Yeah. Now I need to change it to minus tau plus, which I should do time reversal. Here would be T minus capital T. Here would be T. And now I should treat T from minus infinity to that possible.
Same, no?
It's a bit different here.
Counts to
You can see,
yes, just because
yeah, here should be T minus capital T. Here should be minus. And this one should be minus.
this means
No,
this
this
is
is
not.
not. That's not.
This is not.
change T to nothing. After that, I should make it how dot T which here should be T minus T, here should be minus. I move the portion to the left. After that, I should do take minus tau plus tau E independent value, which means I need to multiply all T acted by 1. Okay. Which is here should be minus T, here should be T minus. Okay. So I have x to T, I should multiply that by H. X to tau. If T is smaller than 0. Yes. Here tau equal to 0. It should be H tau. Should be T. They don't have any overlap. If T smaller than 0, there is no overlap. Their multiplication. If you multiply them together, y T should be how much? 0. If I move T a bit to the right, which means T should be positive value. Here T minus they have overlap here, but here T should be bigger than 0, but smaller than T. Why? If T bigger than T, what happens?
Outside.
Yeah, we have all these inside, which is moving. So right now, just small part of T, small part of this square is inside this triangle. So what is this value? It's integral of, if it's 1, if it's 2, integral of this multiplication from 0 to T. What is this line expression? It's slowly 1. So I can write it how. Yeah. And this value is 1 theta. The answer is,
Tau square also better.
and
From 0.
if I replace tau with T, it should be
T square of
Okay. From 0 to t, the equation is like that. Now, if t is bigger than capital T, how should be something like that. Here. How should I move t until it reaches to here? I need to shift it to yeah. So from capital T to capital T, this square is inside the triangle. So what should I write? Y t. What is the overlap?
Is one minus.
Exactly. T minus T capital 2 what or yeah. Okay. Is it 1 multiplied by what is the expression of T? T or again tau square over T minus J the left region when T is bigger than 2. What is happening here?
Go outside.
Yeah. One part of the going out like that. Yeah. Until when when the rectangle completely goes out, which they overlap would be 0. We see when this point reaches to this point, yeah,
T minus T capital is greater than 2T.
yeah, which is
3T.
exactly t minus t reaches to 2t. So t should be before 3t, they have a small overlap. After that, it completely go out. So yt from with
It's not.
exactly this one again, 1 multiplied by tau t, it should be tau square over 2 minus and for t bigger than 3 capital T, and there is no overlap. We multiply them together. We got to be so 180 if for is smaller than 0, it would be 0. For t zero. Capital T 3 over 2. It should be something like that. Okay. Over check the if we move H instead of E, we have these values. What is the thing that we have? Should be the here that and it should be the same, otherwise we may use how much what duration of X for the for this one, this duration for this one, how much is duration of the response? Okay. It should be how much is this duration? Yeah. That means it should be summation of two input and input. If we add this EV is to T, the answer should be that duration. It should have that duration. So if a system is causal, its impulse response is 0 for negative. Which means if we don't have any input before equal to, it shouldn't, it can't predict the future. Yeah, HT0 means before T0, if you don't have any input before 0, you won't have any output before 0. You cannot predict. If this one causal, we should find u 2t plus 1. You know ut. How you find u 2t plus 1 as well? I'm just trying to review them to make sure you will master on that. At first, we should do what? ut plus 1, in fact. Here minus. Now, u 2t plus 1, which means exactly I should exactly I should divide by 2. It has value for t is smaller than 0, which means this system is non-control. For a bounded input, and a stable system has a bounded output. If input is a limited value, output should be the same. The condition means the integral of absolute value of ht should be a bounded value. On this case, we can call it a stable, otherwise that unstable. You know, these are for the system, they are
Linear time.
exactly. They are integral. If the system has invert, not every LTI system has invert here. They can or they cannot. If they have invert, convolution of h by the response of its invert should be delta. 1, 2, 3, you should just keep in mind. You can use it, but it's easier to keep in mind. We want to check the stability of stability and causality of this system. Is it causal or not? Why not? It has the ut. Ut multiplied by anything, which means it would be 0 for t smaller than 0. So ht is 0 for t smaller than 0. So this system is how about stability? I'm looking to find if the function has a limitation. I can go through what is the maximum of sine or cosine?
One.
One. The maximum is 1. Which means if I replace cosine with sine, it should be the maximum value of this function. If two maximum value are limited, I would show it would be a bounded value. But calculate the integral, the answer would be a limited over bounded value. So this is semi stable. So that's the math side. This is really important. If you convolve delta with any function, the result would be equity convolve. If you convolve delta with anything, the result would be that function. Anyone can show me how? we have definition of convolution that a convolution of x and h is minus infinity to infinity x tau delta t minus tau theta. If we multiply delta by any function, the sampling property that it should be only in which in the root of delta. Yeah. In the root of delta is yeah. So here root of delta is yeah. We make the argument 0, which means t should be equal to tau. So I can write this as t. Since t is independent of tau, I can take it out. Take t minus infinity to infinity. Delta t minus tau theta. How much is this integral? 1. So the result would be 60. Which means if you convert delta t with any function, the result will be that function. If I move delta t to t minus theta, this function would go to t minus theta. Step response. If you convert ut with any signal, the answer would be integral of that signal. And the relationship, you know, ut is integral of delta t. So its response is again integral of impulse response. Delta t is the derivation of ut. So impulse response is derivation of step response. Why is it happening?
I did not get the last idea that you were.
You know, ST is impulse responsive system when its input is set. Because the output is. Let me go through the you become bored. So that's the last step. If there is a system with an impulse response of HT, impulse response means if I apply delta T, it equals HT. So we call HT as impulse response. Yeah. If I apply UT as an input, unit itself as an input, I call the ability as ST, which is step response. What's the relationship between input delta T and UT? Delta E derivation of UT. So HT fifth linear system is linear. Remember, first system is linear. Any function you do with the input, you should do with the output. So since system is linear, you make a derivation from input. Again, HT should be derivation of HT derivation of step response. On the other hand, if HT is derivation of ST, ST should be integral of I wanted to just show you one slide just to play with for convolution. I will send a link. For example, Let me just show you. We have a rectangle here, triangle here. How how to put something like that? We can get it. The relationship or something like that, and we calculate it. You can use different, for example, step we rectangle. What's your expectation if I have unit step as an input and one rectangular as the HT? What would be the answer?
Infinite.
By infinite? No.
It will be still because it will not change by time. If rectangle is when the
You know, the last slide I showed you, if you convert beauty with anything, it should be an integral of that function. I have a rectangular, it's integrally integral of a rectangular. What do you think? Integral. It should be something like that. Yeah. It's something like, well, if I have delta with rectangle, convolution of delta with anything,
nothing.
Anything.
yeah, it should be rectangle. Again, or you can negative. If I change delta to delta t minus 2,
It will shift the other function.
yeah, that function which go to the right. Yeah, the right. Delta step. What if delta t minus 2 as an input and input is minus step
Delta
delta
two into plus
by delta.
because it will be anything with the delta, it will be that function which is step and the integral of step is delta. Or not?
The first part was true. Anything with delta is anything.
Yeah.
Yeah.
And
Now
now
step with delta, the result would be step with delta. Step.
yes.
But delta has a time shift.
Yeah, it will be a shift to the right.
Which one?
The step.
That's now true.
Yeah.
The first you were saying delta.
Yeah.
It should be a step shifting by unit. And one triangle and one step. It should be integral of which one?
Integral of step.
Integral of step.
Multiplied by triangle.
Which means when you convert, this is convolution.
Yeah.
We are convert one triangle with one step. Convolution of a step with anything is integral of that function. Okay. It should be integral of triangle. It should be where we anything else you wanna try? Two triangle.
what should be the order? 1t another t multiplied is t over the square if you're integral. It should be, the order should be 3. Polynomial with 3. And if you calculate the 3, the order is 3. You can see both of them are from -1 to 1, but the answer should be from -2 to plus. So you can take it to find any or 5 here. How about let's try one. At first delta. This is sin pt multiplied by step. With delta, it should be the same function. If I change to delta t minus 2, it should go to unit 2.
Yeah.
Right. Yeah. If I change it with step,
And the
yeah, it integral. It has 1 dt plus integral of sin cosine. So, yeah. 1 sine and 1 cosine. If it's both, integral is broken. So that you can play with these as a tool to find things easier to understand what is happening when you are accomplished. In the next chapter, we will see Fourier transform. We will trying to avoid to calculate the conclusion. As you saw, we just made 2 easy conclusions and it took a lot of time. If it's, for example, sine or cosine, God knows how much it will take. So we will introduce Fourier and Laplace transform to make our lives easier for next chapter. If you have any questions, what's happening? Can I start that or? Can I start that or?
no.
Not for today. Yeah, because I'm thinking for you are. Yeah. Okay, there are Fourier transform tomorrow. Laplace or Thursday. Any question up to now? Is it easy for you understandable or you learned them before that, boring? It's new. It's new. You didn't have. How about you had?
And I just totally forget about it.
So it's not bad to review really quick for 12 minutes. Because we need them. I showed you in the beginning of last session that we need, you cannot believe 2 months ago about becoming one ticket. It was one inductor that it made the system unstable. I couldn't find the relationship of that inductor how I had to start go and see on electromagnetic code how we calculate inductors for different situations to find how much is that value which I can compensate it or know how I can make it stable. My point is the job we are doing, these topics are necessary. Someone can say, oh, they are not useful. But or where I can use it, but for our field, for the work we are doing, we almost use all of them every day, daily job. Yeah. But I don't know, I think for some of students, for some of new graduates, it seems it's a bit tough. They try to avoid the, if you can, we just go through practical things. But my point is, if you don't know what you are gonna see on the oscilloscope or the spectrum, how you will find the system you design or the circuit you design is working properly or not. If you don't know what you're expecting, it does. I think you need, if you wanna do this job, if you wanna work IT designer, we should know about it. Yeah. At the beginning, you may think that's a bit tough, but after a while, if you get to use that, you will see that not that much tough that you were thinking. It would be easier, just need a bit hardworking. After that, that will be much easier. Any question? Thank you. See you tomorrow. I will send one assignment today to you, but you can do it in the weekend, and it's not as long as the second month because if it's not that. I just want to make sure you practice the topics you learn, and I think at the end you will improve it. You will then figure out easier than practical section. Thank you very much.
Is it finished that yet?
Yeah.
A small request, when you're going for a break, or something, please do not keep the door open. Please ensure when you come to the GSM office, please make sure it's closed. So they check the cameras and then picture.
Oh, they were complaining?
Yeah, during the night now, this famous about. Please do not keep the door open.
Here, you know, mobile is I think mobile is rented in the GSM, and we have to follow the and when you came in, please go to the library. Thank you.
And if you wanna go out and come back again, just drop me a text on WhatsApp. I'll go and open the door.
Thank you very much. Thank you.